Now we will see modulus and conjugate of a complex number. Let z a plus ib be a complex number. Then the modulus of z is denoted by this symbol mod z, and it is defined as square root of a square plus b square. Okay, and the conjugate of z, this is modulus, and conjugate of z is denoted by z bar. Okay, and this is equals to a minus ib. Conjugate of a plus ib is a minus ib. For example, z is equals to 3 plus I. Now here we have to find modulus as well as conjugate. So first we'll find modulus. So modulus of 3 plus I is equals to square root of 3 square plus 1 square, which is equals to root 3 square 9 plus 1 10, root 10. And modulus of 2 minus 5i, root 2 square plus minus 5 square, because here it is minus. So root 2 square 4, minus 5 square is 25. So 4 plus 25, 29. So 29 is the modulus of this number. Now what about conjugate? So conjugate of 3 plus I is 3 minus I. Similarly, conjugate of 2 minus 5i is 2 plus 5i. Okay. Now we'll define one more term, multiplicative inverse. Now multiplicative inverse of complex number z is denoted by z inverse or 1 upon z. Okay. Now since this z is equals to a plus ib, now we'll derive formula to find multiplicative inverse. So here z, let z be a complex number, then multiplicative inverse of z is z inverse or 1 upon z or 1 upon a plus ib. Now we rationalize the denominator, means will multiply by the conjugate of a plus ib, that is a minus ib, will multiply as well as divide. So numerator will get a minus ib. In the denominator, that identity will use a plus b multiplied by a minus b. So a square minus ib square, a minus ib upon a square minus I square b square. Now see, a minus ib upon a square, I square is minus plus b square. Now we have seen here that modulus is root a square plus b square. So from here we can find mod z square, squaring both sides, we'll get a square plus b square. So a square plus b square is nothing but mod square. Okay, so here we'll write a square plus, at the place of a square plus b square we'll write mod z square, and a minus ib, conjugate of a plus ib is a minus ib. So conjugate of a plus ib is a minus ib, and conjugate means z bar. So the formula to find z inverse is conjugate of z upon mod z square. Okay, this is very important relation. Or you can also write, now transpose this term, so mod z square is equals to z bar upon z inverse or z bar multiplied by z. So mod z square is equals to z multiplied by z bar. This relation is also important.